Hey guys, today we're going to learn how to do 7.8 inverse normal. So that's going to be working backwards from the normal distribution. So in a normal distribution, I give you the performance, the mean, and the standard deviation. You have to calculate the z-score and then find the percentage either using the chart or the calculator, whichever one you're more familiar with. For an inverse normal, I'm going to give you the percentage that you have to look for. Then you have to find the z-score and ultimately work backwards in order to solve for x. Okay, so first thing we need to know is what is a percentile. A percentile of the distribution is a boundary value that separates the lower percent of the data from the upper percent. So looking at this little distribution here, I'm seeing that this is the 90th percentile. That means that 90% of my data is to the left of that value and 10% is to the right. So whenever you see the word percentile, that's going to tell you that that is the percent to the left of the distribution, which is good because in a z-score chart or a standard normal distribution table, those values are the percent to the left, which is the one tricky thing about this lesson is that you always have to be thinking what's the percent to the left. So we're going to be looking in the chart, and I want to see where my 40th percentile is. So again, the mean separates 50%. So if I'm looking at the 40th percentile, it's going to fall a little bit to the left of the mean. 40% of my data is going to fall to the left. That also means that 60% of my data is going to fall to the right. But I don't really care about that because the table doesn't give me the percent to the right. So 40% as a decimal is 0.40. What you're going to do with that 0.40 is you're going to look in your table and find all the way within all of these values, you're going to find the number that's closest to 0.40 without going over the percentage. So if it's 0.40 and it's to the left of the mean, then that's going to be a negative z-score. So I'm looking over here to my right side. Again, I can't write on that right side, but I'm looking for 0.40, as small as I can get. And if I'm looking, I see negative 0.25 and negative 0.26. So negative 0.25 is 0.401, negative 0.26 is 0.39743. So that is the closest value without going over. So the percent that I'm looking for that I found closest was 0.39743, which was negative 0.26. And that would be the z-score that I'd use to work backwards. Now I could also phrase these percentages a little bit differently. I could say the bottom 80%. The bottom 80% is also still the 80th percentile. So I'm looking for 80% in my distribution, which is 0.80. So I look in my table, I know that it's to the right of the mean, so that's going to be a positive z-score. Look to find 0.8, closest value without going over. I see 0.84. So check out that table, make sure you see the 0.84, and you can tell that that is the closest value to 80% without going over. Now this is where it gets a little bit tricky. So we have the top 15%. So if I say the top 15%, you have to remember that you're always looking for the bottom percentage. So the top 15 would be the bottom 85. So the percent that you're looking for, the decimal that you're looking for, is actually 0.85. Okay, so for 0.85, I want to find the value that's closest without going over. Looking for 1.03. 1.03 is the z-score. Okay, and then we have the middle 60%, and that is another little tricky one that we're looking for. So the middle 60%, I'm going to be looking for two percentages overall. So if this is the middle 60%, this red line is in fact 60%, 60th percentile. So for the red line, I can go ahead and look for 60% without going over. So 60% without going over is going to be 0.25. Okay, now for the other one, this here blue line, if it's 60% in the middle, that means that there's going to be 20 and 20 left over on the tails because there's 100% total on the distribution. So 20 and 20. So that means to the left of the blue line is 20%. So now I'm looking for 20%. I accidentally wrote this incorrectly. So this is going to be 0.60 is what I looked for in my graph for that red line, and that gave me a z-score of 0.25. Now for the other side of it, I'm looking for 0.20, and then I'm going to find the value that's closest to 0.20 without going over. Okay, and sometimes it takes you a little bit of work to look for those numbers, but I see it's negative 0.85. Negative 0.85. So now there's two z-scores that I have to look for in order to solve for the distributions. All right, so let's try some example problems. On a standardized test, scores are normally distributed with a mean of 400 and a standard deviation of 80. So what score would you have gotten if you were in the 80th percentile? So the 80th percentile is 80% to the left, 20% to the right. So I look for the number closest to 0.80 without going over. And I think we already did that back up here, so I found that it was 0.84. So 0.84 is the z-score. And I set that equal to my z-score formula, which is x minus the mean over the standard deviation, which is 80. And then from here, all I have to do is algebraically work backwards in order to solve for the distribution, that performance value. So I multiply 0.84 by 80. That's going to give me 67.2 equals x minus 400. Add 400 to both sides. And that means that my performance value that I'm looking for solving is 467.2. So for inverse normal distribution, instead of looking for the actual z-score and looking for the percent, now my answer is going to be an actual performance value. All right, second example. On a standardized test, scores normally distributed. Again, we have the same situation, so mean is 400, standard deviation is 80, and this time we want the top 27%. But we have to remember that the top 27% can't be found in the chart. So instead, you have to use the bottom percentage, which is 73%. So I'm looking for 0.73 in my table. So 0.73, that's going to give me 0.61. So my z-score that I just found is 0.61. And then I use that formula for z-scores to solve for the x value. Again, I'm just substituting the mean value in and the standard deviation of 80. So 0.61 times 80, you're always multiplying by the standard deviation first. That gives me 48.8. X minus 400. Add 400 on both sides. X equals 448.8. Okay, so the one step further that you had to do for that question is you had to say, if I'm looking for the top percentage, what's actually the bottom percentage? And then the middle 40%, that's the most annoying one to do. So the middle 40%, that means that there's 30% and 30% left over on the tails. So that's kind of, I would always just suggest drawing these little bell curves just so you can know like what the percentage is that you're looking for. So for this green line, I'm looking for 30%. However, for the red line, I'm looking for 70%. And I also just realized that I made a mistake up top. For that middle 60% that I found here, the red line shouldn't be 60 because that's 60% is in the middle. The red line should be 80%. So that was a big mistake that I had just made. Hopefully you at least caught it or maybe considered catching it. But so 60 plus 20, I should be looking for 80%. So 80% is going to be 0.84. And it should be relatively close to the value that you get for the negative side of it as well. Okay, so back here, middle 40%. So let's start over. We've got 30% to the left of the green line, 70% to the left of the red line. So I look for 30% in my distribution. 30% is going to be it's taking me a little longer to find this one. Negative 0.53. And then you just solve those backwards like we've been doing the entire time. And then for the red value, I'm looking for 70% in my value. It should be around 0.53. So 70%, I find that it's going to be 0.52. X minus the mean over the standard deviation, and then just working backwards to solve those values. So negative 0.53 times 80 plus 400. So that gives me the value of 357.6. And 0.52 times 80 plus 400. That gives me 441.6. So what two scores would it represent? The middle 40%, that'd be 357.6, 441.6. So don't forget to add those distribution values or add those percentage values when you're trying to find that red line, because we have to account for all of the percent that's to the left of